You don't really have to worry about rolling on something fragile like your table or glass, for instance. But with these dice, you've been asking for it, so we're gonna do it. We're gonna make some dice in the forge that we made last time. So we've got 3 different materials here, and I'm gonna show you how to work them all because they're very different. And you'll notice that these are cylinders, and so I'm gonna show you a different process for making those as opposed to this piece, which was a square bar. We're gonna start with the easy one today. We're gonna go with the steel, and then we'll move into the others. So since it's already square, we're just gonna stand it up on the corners and knock those down just a little bit so they're not so sharp. We'll turn it, hit our next corners, just go all the way around. Steel you can work reasonably cold. Now this is still plenty hot enough to burn you. This is what we call black hot. But this low carbon steel can be worked all the way down to this temperature right here. But definitely hot enough, like I'm feeling a lot of heat right there. We'll just brush off some of this scale. This is the carbon that comes out and is separated from the iron of the steel. Because steel is actually not on the periodic table, it's an alloy. So it is actually a mix of carbon and iron, and it's generally less than 1% of carbon. That's actually considered a high carbon steel. This is probably more like 0.2% of carbon, so this is a mild steel. So we're just going to give that another heat, and since it was already in a cube form, we're ready to stamp our numbers on that bad boy. This is always nice. So this is how hot this stuff gets. Isn't that amazing? Now if you have number stamps, this becomes very, very easy. So you can just take your number, set it on top, and now it's in there. Now you'll notice it's a 6-sided die, but I put a 7 in there, because if you're making your own dice, why not? So just for me, I actually like to sign my dice by making a triangle out of the 3 dots on the side that's supposed to be a 3. That's just what I enjoy doing. We'll just brush up these sides, make it nice and clean and pretty. There we go. So we're just gonna set this aside and let it cool. If we quench it right now, we could crack it. So here's an example of the cracking that can occur if you quench it at too high of a heat. This is solid steel, and it'll break like glass if you quench it at the wrong temperature. While this one cools down, we're gonna move on to the copper. So copper is on the periodic table, it's number 29, and it melts just a hair under 2,000 degrees. So this forge will actually melt that copper if we're not careful, but fortunately it doesn't get too much hotter than 2,000 degrees, so we should be safe as long as we're paying attention. So this is ready because it's got a dull glow. And so we will go ahead and take it to the anvil. I'm just gonna cut off a section of this. Now this, we're gonna quench. Check this out. And you get so much of that color back. So that's at a nice glow right there. So we can go ahead and forge this. Now since I wanna make a cube out of it, this is what's called upsetting. And so I will just drive the top down, just gently, flip it over, because you can tell that it's super flat right there. The anvil hits back. So when I drop my hammer, it'll bounce. But copper is what we call a dead metal, so the copper will actually absorb the hammer strike. I'm dropping the hammer on that, and it does not want to bounce back. But the anvil strikes it back on the bottom side. So working copper, even though copper is softer than steel, is actually harder because you have to swing the hammer and then pick it up every time, whereas steel, you get that bounce. This is a steel ball bearing. On a good anvil, it acts like a bounce ball. The same thing with a hammer. I could drop a hammer and it bounces back. So you can see it's starting to go kind of hourglass, and that's perfect because most of the work is happening at the 2 ends. And so we're gonna have to flip this over on its side and bring that hourglass back down and make a rectangular prism out of this. If you look really close in there, you can see some of that copper color is starting to come back. Now copper will do something called work hardening. So as I'm hitting it with the hammer, it's getting harder and harder. And so when I put it back in the forge, that releases a little bit of tension, but I'm gonna show you the secret sauce on how to make this metal get soft again. So this is how you're going to get your copper to be soft again. You're gonna pull it out at a really high heat and immediately quench it. There you go. And that is nice and cold and very soft. We've got these 2 sides which are not perfectly perpendicular to the anvil face. They're kind of tilted this way if you can see that. You can actually see that this side is a little bit higher, and so we have a rhombus instead of a rectangle. So all we're gonna do is we're gonna take this high side and we're gonna draw a diagonal through it to this bottom side. I'm gonna stand it up on those corners. I'm just gonna knock it down here. Yeah, I went a little too far, so we're just gonna do the same process from this corner down now and try to fix that. Okay, let's toss that back into the heat and keep going. So the next thing we're gonna do is we're gonna break the corners down. So that means we're just gonna keep them from being too sharp, so that when you roll them on stuff, you don't cause as much damage. Copper stays soft for so long. You can work it quite a ways, but keep in mind that the cooler it gets, the more it work hardens. And so you just have to make sure you stick it in your quench bucket every now and then to keep that from getting too hard. We've got all the corners broken, but one of the issues that we have is that the corners are very large and flat, so sometimes it can stand up on those. And also it kind of created high spots in some of these areas just right along the edges. And so we're going to want to take those down, but I've got a flat die on this hammer, so we'll just gently planish that surface. And we're just going to take the rest of the heat out of this. So there we go. And now copper is soft enough that we can go ahead and stamp our numbers in cold, just like this. Now if you're a nerd like me and you play Dungeons and Dragons, I give everybody a +1 on their hand-forged dice. Moving on to the aluminum. This is the hardest one. So aluminum is number 13 on the periodic table, which actually means it has 13 protons, and its melting point is about 1220 degrees. So it will definitely melt in this forge, so you gotta watch it carefully and check it often. Oh, there we go, it left a black mark and it stayed. It's slowly burning off, that's totally acceptable, but that's ready to forge. So let's go ahead and cut off a nice chunk and make our die. This is called a flatter. You don't have to have one of these, but it kind of makes it easier. Just set it on top and smack it. Definitely not perfect, but it's pretty good. I'm happy with this. Let's put in the numbers. I've decided just to go with some wild numbers on this one. Got a 10 on that side, got a 12 there, and an 82 there. And now you know my birthday. My birthday on 3 faces. I'll put my wife's birthday on these other ones, but I'm single, so I'll finish this when I get married. So here we have our dice, but as you can tell, they really could be polished up a little bit and look a lot better. So we're gonna go ahead and do that now, and you're gonna see the finished product. So with the aluminum, if we put it in this steel wire wheel, it's actually going to heat up and score the metal, and it's gonna look terrible. So I've got my Dremel out, and we've got this little brush, and that's how we're gonna clean this one up. So here's the dice we made today. They're all polished up and looking nice. And then here's a few that my son made. And also one more. There's an 18-sided die that we made out of aluminum just recently. Super fun. Why don't we try these out? Now with normal dice, you don't really have to worry about rolling on something fragile like your table or glass, for instance. But with these dice, such a fun project. Thank you for joining me today. And if you had fun time too, make sure you join us for the next one. And remember, let the random happen. Oh, hey, check this out. Got a piece of meteorite here. If you want to see me forge something out of this, just let me know in the comments.